Today we are going to discuss the sequence model. In sequence, this model, as the word indicates, what should be the sequence? Whether the sequence should be 1, 5, 4, 3, 2, or it should be 1, 2, 3, 4, 5, or maybe like this one 4, 3, 2, 1, 5. It could be any sequence. So what is to be decided? This is applicable when there is only one operation being performed on one machine. If the number of operations are more than one, in that case, what should be the sequence? Let us, we will discuss that thing also. Or if the number of operations are more than 2, again what should be the criteria which has to be followed? So Johnson has given the rules. Johnson, the scientist who have given this rule. So we'll, on the basis of Johnson's rule, we'll decide this sequence model. So let us take the simple case. Let us take the simple case. There is a job 1, 2, 3, 4, 5. There are 5 jobs, or there is only one lathe machine on which the operations are being performed, and the time consumed is 4, 1, 5, 2, 5. Now here, whatever the process you are using, maybe you go with 1, 2, 3, 4, 5, it hardly matters, because there is one machine which is the lathe on which the operation are being performed. The best way I take a 5 box here, 1, 2, 3, 4. So out of that one, if the time is given in minutes, let us assume the time is given in minutes. In lathe machine, these operations are being performed and they are taking the time of 4 minutes, 1 minute, 5 minutes, 2 minutes, 5 minutes. Out of that one, choose the least time. It is 1 here, and the job number 2, it has been cancelled. And rest of the one, we are left with 1, 3, 4, 5. And when we are going with again the minimum time is 2, job number 4. Next is 4, the job number is 1. Here it is tie. You may mention 3 and 5. Now what happened here? The processing will start. The processing will start at time. Here it will be mentioned start and finish. If I put it like this one, if I set a watch like this one, what is the sequence? The sequence is very much clear. The sequence is, here it is 2, this is the sequence. Let us rub it. First of all, mention the sequence. Sequence is, first of all, there will be the job number 2, then 4, then 1, then 3, this is 5. And what is the time which is being consumed? On a 2, the time consumed is, and this is the job number 2, the time consumed is 1 minute. It is given in minutes. This is a sequence. On job number 4, the time consumed is 2 minutes. Job number 1, the time taken is 4 minutes. Job number 3, the time taken is 5 minutes, and this is 5. If I set my watch at a 0 plus 1, it will be finished at 1. Because the operation, the processing is being done on the lathe machine, so immediately we'll shift it here 1. This will take time 2 minutes. So the second operation will be completed, or the second job will be finished by the 3 minutes. We start with the 3 minutes, another 4. If we add it 4, this becomes 7 minutes. And when on the completion of the 7th minute, we will take this job, and it is taking 5 minutes, this becomes 12. And 12, again this 5, this is 17. So if you look at here, within the 17 minutes, you are able to process all the 5 jobs. And what is the minimum time? Means there is no we are not going to, we will not remain idle, the whole of the operation being occupied. Now let us take the another one. We will take one more problem in continuation with the same one. I rub it here. So this is the sequencing model. And let us have the one more problem. Here the jobs are 5, the jobs are 5, this is given to you, and the operations are being performed are 2. One is being performed on a lathe machine, another one is performed on a grinder. Basically, you have done all the operation on a lathe machine, and this is the time consumed. 4 minutes. This data is given 4, 1, 5, 2, 5. This is the data which is given to us. 4, 1, 5, 2, 5. And this is the data given to us 3, 2, 4, 3, 2, 4, and 3, 6. This is the data which is given to us. Here, the number of jobs are n jobs, and 2 machines, So this is the case, or n jobs, 2 machines. How to solve these type of problem? Look at here. Again, how many jobs are there? There are 5 jobs. Make a 5 block. 1, 2, 3, 4. 1, 2, 3, 4, 5. There are 5 blocks. First of all, the operation will be done on a lathe machine, and after that we perform the operation on a grinder. So this is the basic. If you are aware of this thing, it is better. If it is not given, then in that case you may go with any one of them. Now out of that one, choose the least value. When you are choosing the least value, from all these values, minimum is 1. It is on the left side or on the right side. If it is on the left side, so this is the job number 2, which we will start with the job number time, means if we will follow the correct sequence, means we need not to wait more. So this is the best part of this sequence model. Means if we spend more, if we use 1, 2, 3, 4, 5, in that case we may have to wait more. Means the machines will get engaged in that time. Means we'll have to spend more resources from our pocket. This is the significance of this sequencing model. And out of this one, choose again the least value. This is the 2. Again, this is job number 4. This has been cancelled out. Now rest value 4, 3, 5, 4, 5, 6. The least value is 3. So on the right hand side, we'll put a 1. This is on a job number 1. So out of that one, the least value is again 4. It is on the right side, put on the right side, this is 3. And we are left with only this one, this put a 5 here. So this is the sequence 2, 4, 5, 3, 1. Now let us start. What happened here? This is the job 2, 4, 5, 3, 1. This is the sequence. Look at here, this is the sequence. Is it okay or not? Now on lathe machine, on lathe, on grinder. On lathe, on grinder. Look at here, lathe. On lathe, look at here. This is what is the time here? On this 2, this time is on a lathe is 1. Clear? On 4, this is time is 2. On 5, the time is 5. On 3, the time is again 5. It could be in minutes or it could be in hours also. Normally the best value is it could be in minutes. This is 4 here. Is it okay? This is what I have done. What I have done in a sequence 2, 4, 5, 3, 1. For 2, I have mentioned 2, 4, 5, 3, 1. Now here, if you look at here, it takes 1 minute on a lathe machine. And 4, job number 4, it takes 2 minutes. Job number 5, it takes 5 minutes. Job number 3, it takes 5 minutes. Job number 1, it takes 4 minutes. Now let us start with in, out. Look at here. In, out. I put a grinder here, little bit far away. Now here it is in. When we start our watch at 0, 0 plus 1, by the first minute, your job number 2 will be completed. After the completion of job number 2, for grinding operation, what happened here? You can mention what is the time required for hair grinding operation. Time required. Here it is the time required. Time required. Here it is a time required for grinding operation. 2, this is 2 here. And for 4, this is 3 here. For 4, this is 3 here. For 5, it is 6 minutes on a grinder. Job number 3, it is 4 minutes. It is 4 minutes. For job number 1, it is 3 minutes. This is the sequence and the time taken. Again, let us check it. For the job number 2, it is 2 minutes. For job number 4, it is 3 minutes. For job number 5, it is 6 minutes being taken on a grinder. For the job number 3, it is taken 4 minutes. For job number 1, it is being taken 3 minutes. Again, in and out. We can't start the operation. We'll get the job, this second job, and this is the time taken. 1 ਮਿੰਟ ਤੋਂ ਪਹਿਲਾਂ ਸਾਨੂੰ ਗ੍ਰਾਈਂਡਰ ਮਸ਼ੀਨ ਤੇ ਜੌਬ ਨਹੀਂ ਮਿਲ ਸਕਦੀ। ਕਿਉਂ? ਕਿਉਂਕਿ ਗ੍ਰਾਈਂਡਰਿੰਗ ਜੇ ਲੇਥ ਵਾਲੀ ਮਸ਼ੀਨ ਹੀ ਗ੍ਰਾਈਂਡਰ ਤੇ ਆਊਗੀ। Then it becomes 1 plus 2. 1 plus 2, 3 minutes. Clear? Again, this is here 1 plus 2, this is 3 minutes. Is it okay so far? And here it is, look at here, look at here. What happened here? When the job, second job means the sequence number 4 job, it is being freed at 3 minutes, and at the same time from this grinder is getting free. This 3 plus 3, it is 6. Is it okay so far? Now here it is 3, here it is 5 plus 8. What happened here? The grinder is free at 6, but the previous job, the lathe job, it being available to the grinder at the 8 minute. Means here the grinder is free for 2 minutes. Means grinder have to be remain ideal for the 2 minutes. 8 plus 6, this is 14 minutes. Here it is 8 plus 5, this is 13. And this is free at 14 minutes. So means the grinder is already engaged. Means immediately when it will free, this job will be available. This 14 plus 4, this is 18. Similarly, 13 plus 4, this is 17, and this is 18, but the job is available 18 plus 3, this is 11. If you look at here, the for 4 minutes means 17, total time elapsed is the 21 minutes to complete whole jobs. Means in a sequence, lathe followed by the grinder. What happened here? It means this will be freed by 17 minutes and the overall process will be completed by 21 minutes. Means the lathe machine will remain vacant at the end of the 4 minutes, at the end for 4 minutes. Is it okay so far? And whereas if you look at here, the grinder, 1 minute here, 1 minute here in the very initial, and 2 minutes here, and 2 minutes because the job is not being, and it is also free for 3 minutes. So this is the sequence which has to be followed. Similarly, you can plot it on all Gantt charts also, but we need not to work on that one. We'll take one more problem in continuation with that one also. I am going to rub it and taking one last problem related to that one in a sequencing model. What is that one? Look at here. Instead of let us assume what I do, I take the same data. I'm rubbing it. I'm taking the same data. What happened here? We'll do, this is 4, 1, 5, 2, 5. This is 3, 2, 4, 3, 6. This is operation, let us assume, this is the facing operation. This is turning and this is threading. These are the operations which are being performed on a different machine. Maybe here it is 2 minutes, here it is 5 minutes, 1 minute, maybe 6 minutes, 4 minutes. How to solve these types of problems? Look at here, what to do? Here you have to make it n jobs 2 machine, means you will club facing plus turning, then turning plus threading. Turning plus threading. Basically make it like this one. Facing plus turning. Clear? When you are going to add it 4 plus 3, this is 7. 1 plus 2, this is 3. Then 4 plus 5, this is 9. 2 plus 3, this is 5. This is 5 plus 6, this is 11. What happened? This is the second one. Second one, what happened? Look at here. This is turning plus threading. Turning plus threading. Look at here. This is 3 plus 2, 5. 2 plus 5, 7. 4 plus 1, 5. 3 plus 6, 9. 6 plus 4, 10. Now, what should be the sequence? Look at the sequence. How many jobs are there? There are 5 jobs. So, make a 5 box. 1, 2, 3, 4, 5. What should be the sequence? Again, this is what we discussed in the last problem. We are going to repeat the same process here. What happened? N jobs, 2 machines. Now, this is N jobs, 2 machines. And out of that one, the least value is 3. The least value is 3. It is on the left side. This is for job number 2. So, out of remaining, again the least value, here we are getting a least value 5, 5, 5. I choose this 5, this become a job number 4. So, when I am choosing on the right hand side 5, maybe I choose this one, this is 1. Then out of that one, choose the least value. Out of that one, choose the least value. Again, this is 5. This is job number 3. So, this is job number 5. So, this is the sequence. Now, let us solve this problem. Let us solve this problem. Clear? Now, how to solve this one? Here, we have to perform 3 operations. Look at here. What is this is the jobs. We have been given the jobs 2, 4, 5. I put a line like this one. 2, 4, 5, 3. Here it is 1. Clear? Now, what should be the order? What should be the order? I mention it here, it is facing. I mention it as facing. When facing, what is the time? What is the time for facing? This is for job number 2, it is 1. 4, it is 2. For 5 job number, this is 5. For job number 3, it is 5 minutes. For job number, it is taking 4 minutes. Is it okay so far? Now look at here. This is in, this is out. This is in and out. This is the facing operation. We'll start at 0 minutes. We'll start at a 0 minutes. Set our watch at 0. 0 plus 1, it is 1. At the first minute, this job will be free. I am going to complete the full facing operation. 1 plus 2, this is 3. Clear? At the third minute, I am going to take the job number 5, which is taking 5 minutes. 3 plus 5, 8. 8 plus 5, this is 13. 13 plus 4, this is 17. Within the 17 minutes, all the operation on the facing, for all the 5 jobs, it will be completed. Now, what is the next operation? Next operation is turning. Next operation is turning. And what is the time required? What is the time required? This is important. What is the time required? Look at here for turning. Job number 2, it is 2. Job number 4, it is 3. Job number 5, it is 6 minutes. Job number 3, it is taking 4 minutes. Job number 1, it is taking 3 minutes. Now, what is in and out for the turning operation? Look at here. In and out for the turning operation. Look at here. Means at the first minute, you will get the first job, means you are getting the job number 2. It is taking 2 minutes, 3 minutes. And 3 minutes, you are getting the job number this 3. 3 plus 3, this is 6. Clear? At the 8th minute, you are getting the job number 5. By the time this machine will remain idle. 8 plus 6, this is 14. And at the 30th minute, this is free. 13 plus 4 is this is 17. And immediately the same job, 17 plus 3, this is 20. Clear? Now we are left with one more part, that is the threading. That is the threading. For threading, again you can note down the minutes. For the second job, it is taking 5 minutes, in, out. For the job number 4, it is taking 6 minutes. Job number 5, it is taking 4 minutes on a threading. Job number 3, it is taking 1 minute. Job number 1, it is taking 2 minutes. Now, at the third minute, you are getting the turning operation to be performed. 3 plus 5, this is 8. Clear? And this is far, and this job is free, but we will start at the 8th minute. Clear? So this job will remain ideal. 8 plus 6, 14. This is 14 plus 4, 18. Again, this is 18. At 17th minute, this job is free. 18th plus 1, this is 19th. At 19th, this threading operation, it is freed at 19th, but the previous job, it is coming at the 20th minute. This 20 plus 22. So total time elapsed means to complete all the activities is 22 minutes. Within the span of 22 minutes, you are able to process all them. And if you don't follow this sequence, maybe it takes more time. And means 5 minutes, 22 minus 17, 5 minutes, this facing machine will remain ideal. And this is 1 minute here, 1 minute here, rest is 2 minutes here. 1 minute is here, if you look at here, and 2 minutes is here. Because in a sixth minute, this turning operation, but the previous job is coming at the 8th minute. 1 plus 2, and 1 minute is, and here if you look at here, this is a fundamental, here it is, if you look at here, this is the fundamental bridge. This is 14 plus 4, this is 18. Look at here. And here it is 18 plus this is 21. And here it is 20, rest is okay. This is, if you look at here, this is free, 18th and 18th, there is no change. This is 21 plus 2, this is 23, this is 23 actually. This is 6 minutes, this is 6 minutes. Look at here, this is 6 minutes. And here it is, this job. 1 minute is here, 2 minutes is here, rest. Again this is 2 minutes is here, 2 plus 1, this is 5 minutes. 5 minutes, this turning operation machine will remain idle. And here if you look at here, the last one, first 3 minutes, it will remain ideal, this threading operation machine. So this is the sequence which has to be followed. There is a minor mistake. I have put it 17th, but the job is being engaged at 18 minutes because the machine remained engaged at that time. So that's it from my side. What we have discussed the sequence model starting with the n jobs, one machine, n jobs, one machine. We started with this one, and we go with the n jobs, 2 machines. Then we done n jobs, 3 machines. We can go up to the m machines also. So we have to adopt the same practice. That's it from my side. If you have any question, you may ask. Otherwise, thank you very much.